You got to solve the equation 5 to the power 2x plus 5x to the power x equals 12. Now in order to solve this, you can simply convert this into a quadratic equation. You can take this 5 to the power 2x as 5 to the power x to the power 2 plus this is 5 to the power x, this 12 is taken to the left hand side, minus 12 equals 0. We will now take 5 to the power x is equal to t. Then this will be converted into a simple quadratic equation of t. Instead of 5 to the power x, we apply t. Then this will be t squared t minus 12. This is a simple quadratic equation of t. We can factorize this as t plus 4 into t minus 3 equals 0. This will give us t equals minus 4 or t equals 3. Now t is something we have introduced. We have to now get rid of t. We replace t by 5 to the power x. Then this will give us 5 to the power x equals minus 4 or 5 to the power x is equal to 3. 5 to the power x is equal to 3 means, now from this we can make x ln 5 to the power x is equal to ln 3. We take the logarithm on either side to the base e. You can use some other base even. X ln 5 is equal to ln 3. So x is equal to ln 3 divided by ln 5. This will give you the answer x equals 0.683. Now this solution 5 to the power x equals minus 4 will not lead us to any solutions because there will not be such x. When you raise a positive number to any power, it will always be positive. So you will never be able to find an x which will give you a minus 4 here. Therefore this will be discarded. No solutions from this. In this we've got to make y the subject in the equation. Ln y plus 5 minus ln y is equal to 2 ln x. Now we know some rules of logarithms. We can apply those rules of logarithm here. There are two rules that can be applied here. One thing is log minus means division. So we can write here ln x plus y divided by 2, and again this 2 could be taken inside the logarithm as a power, and then this side will be ln x squared. So on either side you find ln. Therefore we can get rid of ln by taking anti-log. So in that case y plus 5 over y is equal to x squared. Now this is a simple equation, algebraic equation, to make y the subject. In order to make y the subject, we first of all multiply this y onto the other side, cross multiplication. Therefore y plus 5 is equal to x squared into y, and this y is also taken to the right hand side. It will go as minus 5. So 5 is equal to x squared by minus y. Therefore 5, now the y is common here. Since we want to find actually y, we will isolate it by taking it out. So 5 is equal to y into x squared minus 1. So now we divide this x squared minus 1 to the other side, giving the y in terms of x. Finally y is equal to 5 divided by x squared minus 1. Y is equal to 5 divided by x squared minus 1. Here you got to solve this inequality. The inequality says 3 into 2 to the power x 3x plus 1 is less than 8. First of all, I can divide both the sides of this inequality by 3 without changing the inequality because it is a positive number. Then I can say 2 to the power 3x plus 1 is less than 8 over 3. Now take logarithm on either side because in order to find x here, this is appearing as a power, we have to take logarithm on either side. So ln 2 to the power 3x plus 1 is less than ln 8 over 3. 3x plus 1 ln 2 is less than ln 3 over 8. This power could be taken to the front as a coefficient. When it is appearing as a coefficient, you can again put it inside, vice versa. Now what we want is x. So we isolate 3x plus 1 here and divide ln 2 both sides by ln 2, then the ln 2 goes to the other side. Therefore, which will result as 3x plus 1 less than ln 3 over 8 over 3 divided by ln 2. 3x plus 1 less than ln 8 over 3 divided by ln 2. Again, I can write this as ln 2. This plus 1 could be taken to the other side as minus 1. So 3x is equal to ln 8 over 3 divided by ln 2 minus 1. Then x is equal to 1/3 ln 8 over 3 minus divided by ln 2 minus 1, whole thing divided by 3. Since they want the exact value, we can leave this answer in this way also. If you really need, you can do another simple simplification. If you expand this as ln 8 minus ln 3, ln 8 could be written as 3 ln 2, then ln 2 ln 2 goes off here. That's a simple thing, but this is okay. We've got to solve the equation ln x plus 1 minus ln x 2ln equals 2ln 2. Here also we can apply rules of logarithm. On the left hand side we can apply ln x plus 1 over x minus means division. On the right hand side we can say ln 2 to the power 2. The coefficient is taken inside the logarithm as a part. So now we have ln x plus 1 over x is equal to ln 4. On either side it is ln. Therefore we can take antilog and get rid of ln, which will give us x plus 1 over x is equal to 4. To solve this one, take x to the other side. X plus 1 is equal to 4x. You multiply both sides by x. Then x plus 1 is equal to 4x. You leave 1 in the left hand side and take x to the right hand side. So 1 is equal to 4x minus x. 1 is equal to 3x. X is equal to 1 over 3. In this question, we've got to write 2 to the power y equals 9 to the power 3x in the form y equals kx. So the step number 1 is to take logarithm on either side. Therefore we can write logarithm of 2 to the power y is equal to logarithm of 9 to the power 3x. The power could be taken to the front. Y ln 2 is equal to 3x ln 9. You divide both sides by ln 2 to isolate x. Y is equal to 3 ln 9 divided by ln 2 into x. So now we have written it in the form y equals kx, where k is 3 ln 9 divided by ln 2. In this question, we are supposed to find a and p. The graph of this equation y equals a x to the power minus 2p in logarithmic form is given as this, and we are given 2 points on the straight line. So what we should do is, first of all, we take logarithm on either side of this equation and convert it into a straight line of ln y and ln x. We can do it like this. We can do it like this. Say ln y is equal to ln a into x to the power minus 2p. Now this is a product. This product could be written as a sum. So ln y is equal to ln a plus ln x to the power minus 2p. This minus 2p taken to the front. So ln y is equal to ln a minus 2p ln x. Therefore, we can write this as ln y equals minus 2p ln x plus ln a. Now, this is the equation of the straight line given to us. There are 2 points on the line given to us. One point is 1.07 comma minus 1.53. So we apply that we apply that in the equation. The other point is given is minus 0.68 comma 302. So when we apply 3.02 for ln y equals minus 2p into minus 0.68 plus ln a, this could be simplified as 3.02 plus 1, when you multiply this to become 1.36p plus ln a. So when you apply the other point, you get another equation. This is the other point, 1.07 comma minus 1.53. You get another equation. That equation is minus 1.53 equals minus 2.14p plus ln a. Now you want a and p. If you subtract these two, ln a goes off, and then you can find the value of p like this. So ln p will be 1 minus 2. From 1 minus 2 you get ln p, p is equal to 4.55 plus 3.50. So p is equal to 4.55 plus 3.50, 1.3. When you apply 1.3 in the first equation, you get ln a is equal to 1.432. A is equal to e to the power 1.432. Here again another inequality to be solved. It says 2 into 3 to the power 1 minus 2x less than 5 to the power x. So variable appears as an exponent. So best thing is to take logarithm on either side in order to isolate the variable. So we will take ln2 into 3 to the power 1 minus 2x is less than ln 5 to the power x. Now this is the product here. This product could be written as a sum. Therefore ln2 plus ln 3 to the power 1 minus 2x is less than x ln 5. ln2 plus this power could be taken to the front as 1 minus 2x into ln 3 less than x ln 5. Here also power is taken to the front. Now it is just a matter of taking all the x terms to the other side and other terms to the other side. So we will first open this bracket here. ln2, this into this is ln 3, this into this is minus 2x ln 3 less than x ln 5. Right? Should go to the other side. Right. So ln2 plus ln 3 minus 2x ln 3 less than x ln 5. We will leave this ln2 and ln 3 in this side and take minus 2x ln 3 to the other side. Then it will result as ln2 plus ln 3 less than 2x ln 3 plus x ln 5. Now x is common here. We want to isolate it. We take it out, pull it out. Then it will give us ln2 plus ln 3 is less than x times 2 ln 3 plus ln 5. If you simplify this back again, this is ln2 into 3. Sum could be written as a product and vice versa. So less than x ln 3 to the power 2 plus ln 5. This is x ln 6 is less than x ln 9 into 5. So x is greater than ln 6, so ln 45. Here again another ln equation involving ln y and x. So original equation is given as y squared equals a e to the power kx, and they have converted it into a linear format and done the straight line, and they have given us 2 points 1 comma 1.5 comma 1.2 and 5.24 comma 2.7. So what we should first do is to take logarithm of this equation on either side and convert it into a straight line linear format of ln y and x. Let's try and do it first. Y squared is equal to a times e to the power kx. Ln y squared is equal to ln a times e to the power kx. 2 ln y, this is taken to the front. 2 ln y is equal to ln a plus ln k e to the power ln e to the power kx. Now here there is a product. this product is converted into a sum. 2 ln y is equal to ln a plus this kx is taken to the front, kx ln e. So ln e is equal to 1. Therefore we can write this as 2 ln y is equal to ln a plus kx. So now we have this equation 2 ln y equals kx plus ln a, and we've got two different points on this straight line, right? 1.5 comma 1.2. So we will apply this 2 into 1.2 k times 1.5 plus ln a. This will result as 2.4 equals 1.5 k plus ln a. This is equation number 1. We can construct another equation by using the point they had given. There is another point they have given. So that will give us 2 into 2.7 is equal to 5.24 k plus ln a. Now we've got two equations. Right? We will solve those two equations, linear equations, simultaneous equations, and we will find k and a. Once you subtract these two, ln a goes off, and then you will get k. K is equal to 3 over 3.7. When you apply this k value in one of these two equations, you can find the value of a. Now here again we have an equation given ln 1 plus e to the power minus x plus 2x equals 0. This is to be expressed as a quadratic equation in Ex. So what is to be done? Let's see what is to be done. You can write this as ln 1 plus e to the power minus x plus 2x equals 0. Then this 2x is taken to the other side as minus 2x. So ln 1 plus e to the power minus x is equal to minus 2x. Now we can get rid of ln by taking antilog. So you can write 1 plus e to the power minus x is equal to e to the power minus 2x. We have taken the antilog. So 1 plus e to the power minus x could be written as 1 over ex equals 1 over e to the power 2x. Now we multiply the whole equation by e to the power 2x. So when you multiply this 1 by e to the power 2x, it will become e to the power 2x. When you multiply 1 over e to the power x by e to the power 2x, it will become e to the power x, and this will become 1. So this is e to the power x squared plus 1 e to the power x minus 1 equals 0. So this is the quadratic equation they wanted us to do. This is the quadratic equation of Ex. This is a logarithmic identity. So what you should do here is to consider the left hand side and use the algebra and rules of logarithm, simplify it and come out with the right hand side. So let's take the left hand side. Ln x cube minus 4x minus ln x squared minus 2x. This is a minus here, therefore we can apply the logarithmic rule. Minus means division. So x cube minus 4x divided by x squared minus 2x. Right? When you consider the
numerator x is common, you first take it out, then it will become x squared minus 4, and the denominator also, and x is common, take it out, x into x minus 2. Now this could further be simplified, because this x squared minus 2 means x minus 2 into x plus 2, the difference between two squares. So numerator can now finally be written as x into x minus 2 x plus 2, and denominator is x into x minus 2. So x into x minus 2 and x into x minus 2 in the numerator and denominator cancels each other. Therefore, what will remain at the end of the day is ln x plus 2 only, which is the right hand side. So we have taken the left hand side and simplified using logarithmic rules and algebra, and finally come out with the right hand side. Therefore the identity is proven.
This is another equation to be solved involving logarithms. It says ln 2x minus 3 is equal to 2 ln x minus ln x minus 1. This is to be solved for x. So what you should do is we first apply the log rules and get rid of log. So left hand side is log 2x minus 3, right hand side this 2 ln x, this 2 could be taken inside ln as a power, then it will become ln x squared minus ln x minus 1. So ln minus means division, so you can write ln x squared minus ln x minus 1 as ln x squared over x minus 1. Now left hand side is ln 2x minus 3, right hand side is ln x squared minus 1. So you can take the antilog and get rid of ln. Therefore 2x minus 3 is equal to x squared over x minus 1. Now this is a simple equation to be solved. What we do is we multiply both sides by x minus 1, then this x minus 1 will move to this side. So 2x minus 3 into x minus 1 is equal to x squared. If you expand this bracket, it will become 2x squared minus 2x minus 3x plus 3 equals x squared. This x squared is brought to this side, then result in the quadratic equation x squared minus 5x plus 3. You can apply the formula, or you can just apply the quadratic equation in the calculator and get another equation to be solved. 9 to the power x equals 3 to the power x plus 12. What we can do is to convert this into a quadratic equation of 3 to the power x. This 9 could be written as 3 to the power 2 to the power x. This 3 to the power x is taken to the left hand side, minus 3 to the power x. 12 is also taken to the left hand side, minus 12. This 3 to the power 2 to the power x could be again written as 3 to the power x to the power 2 minus 3 to the power x minus 12 equals 0. Now we will take t is equal to 3 to the power x in order to boil it down to a simple quadratic equation type. So this will become t squared minus t minus 12 equals 0. Now this is a very simple quadratic equation. You can factorize it and solve. The factors will be t minus 4 into t plus 3 equals 0.
this will give you t equals 4 or t equals minus 3. Now we can't have the final answer in terms of t. We have to get rid of t, and t is actually 3 to the power x. 3 to the power x is equal to 4 or 3 to the power x is equal to minus 3. So 3 to the power x equals minus 3 will never give you an answer, because 3 is a positive number. When you raise a positive number to any power, it will never give you a minus value. So that means there will not be such x. So this is discarded, and we will proceed with 3 to the power x equals 4. To solve,
use logarithms to solve the equation. 5 to the power 3 minus 2x equals 4 into 7 to the power x. Here also variable appears as an index. Therefore, in order to isolate the x, we've got to make use of logarithms. So the step number 1, we will take logarithms on the either side. ln 5 to the power 3 minus 2x is equal to ln 4 into 7 to the power x. The power here you can write this product as a sum using the log rules. Therefore, ln 5 to the power 3 minus 2x equals ln 4 plus ln 7 to the power x. 3 minus 2x could be taken to the front using the log rules, and this x also could be taken to the front. Then we will have 3 minus 2x ln 5 is equal to ln 4 plus x ln 7. Now we will expand this bracket. 3 ln 5 minus 2x ln 5 equals ln 4 plus x ln 7. So we will take x terms to one side and the other terms to the other side. We will take this ln 4 to the left hand side, minus 2x ln 5 to the right hand side. Then we will have 3 ln 5 minus ln 4 equals x ln 7 plus 2x ln 5. Again we can apply log rules in the reverse manner. We take this 3 inside as 5 to the power 3. So ln 5 to the power 3 minus ln 4 is equal to x ln 7 plus 2 ln 5. So ln, this is again you can apply log rule. Division, minus means division. ln 5 to the power 3 divided by 4 x ln 7 into 5 to the power 2. This 2 could be taken in as a power. So this is equal to ln 5 to the power 4, 5 to the power 3 divided by 4, the whole thing divided by ln 7 into 25. You can use the calculator to get the answer to whatever the number of decimals required. This is another situation of converting an exponential equation into a linear format using logarithms. So this equation y equals a into e to the power px plus p is converted into a linear format taking logarithms, and they have done the line of that straight line, and then we are given two different points on this and expected us to find a and b. So we will first convert this into linear format and then apply these 2 points, because these 2 points should satisfy that linear format. Then we have two simultaneous equations. We can solve it and take A and P. Let's see. Y is equal to A times e to the power px plus p. Ln y is equal to ln A e to the power px plus p. Ln y is equal to, here this product could be written as a sum ln A plus ln e to the power px plus p. Ln y is equal to ln A plus, this power could be taken to the front as a coefficient, then px plus p ln e. We know ln e is 1. It is always 1. Now we will have the equation ln y equals ln A plus px plus p. We will now just simply write it in y equals mx plus p, mx plus c format. So ln y is equal to px ln A plus p. ln A plus p will be our c, p will be our m. Now it is given that these 2 points satisfy this equation, right? Now we will apply those values in the equation. Instead of ln y we can apply 6.585. Instead of x you can apply 6. Then it will be 6.585 equals 6p plus ln A plus p. And again we can apply, instead of ln y we can apply 2.835. Instead of x you can apply 1. So 2.835 equals, this is equal here, equals p ln A plus p. So when you subtract these two equations, ln A plus p goes off and you will get the value of p. So when you subtract these two equations, left hand side will become 3.75, right hand side will become p 5p. So p is equal to 3.75 divided by 5. So p is equal to 0.75. You apply this p value here and find value of A. Again we have to solve this quadratic equation. We will first convert this into a quadratic equation of 3 to the power x. 9 to the power x plus 3 to the power x is equal to 240. 9 could be written as 3 to the power 2 to the power x, 3 to the power x. This 240 is taken to this side, minus 240 equals 0. This could be written as 3 to the power x to the power 2. You can switch these two, plus 3 to the power x minus 240 equals 0. So we take this t as 3 to the power x, then this will become t squared. This is t, this is t minus 240 equals 0. T plus, now this is a simple quadratic equation, we can factorize it very easily. T plus 16 and t minus 15 equals 0. T equals 15 or t is equal to minus 16. We will take this t equals 15. Now this t is something we have introduced, so we've got to get rid of t. T is replaced with 3 to the power x. Then this will become 3 to the power x is equal to 15. 3 to the power x is equal to minus 16. 3 to the power x equals minus 16 we can't proceed with because this will never happen. This is an invalid solution. So we will leave it. We will proceed with 3 to the power x equals 15. In order to find x here, we will take logarithm on both sides. So ln 3 to the power x is equal to ln 15. Now this power could be taken to the front. X into ln 3 equals ln 15. Therefore x is equal to ln 15 over ln 3. We got to solve this equation. Actually we can use some algebra and simply convert it into a quadratic of e to the power x. Okay, let's do it. 2 e to the power x plus e to the power minus x divided by e to the power x minus e to the power minus x is equal to 4. This denominator is cross multiplied onto the right hand side. Then you will get 2 e to the power x plus e to the power minus x equals 4 times e to the power x minus e to the power minus 6. Then you can write this e to the power minus x as 1 over e to the power x. Then you will get 2 e to the power x plus 1 over e to the power x is equal to 4 e to the power x, open this bracket, and 4 over e to the power x. Then we multiply the whole equation by e to the power x. Then this will become, when you multiply this one by e to the power x, this will become 2 e to the power x squared. When you multiply this one by e to the power x, this will become 1. 4 e to the power x squared in the same way, and this will become minus 4. So we will take e to the power x terms to one side, the other terms to the other side. This minus 4 is brought to left hand side, then it will give you 1 plus 4. 4 e to the power x squared, and this 2 e to the power x squared is taken to this side. It will give you minus 2 e to the power x. Whole thing squared here. And then 5, left hand side is equal to 5, and right hand side is 2 e to the power x squared. So e to the power x squared is equal to 5 over 2. E to the power x is equal to plus or minus root 2.5. E to the power x is equal to root 2.5 or e to the power x is equal to minus 2.5. This minus 2.5 is an invalid answer, so this will never happen. Therefore x is equal to ln 2.5. We got another equation of ex to be solved. What we can do is, first of all, we will convert this into a quadratic equation of e to the power x. We can do it in the following manner. 3 e to the power 2x minus 82 e to the power x plus 27 equals 0. This e to the power 2x could be written as 3 e to the power x squared minus 82 e to the power x plus 27 equals 0. Now we will take e to the power x as t. Then this will give us 3t squared minus 82t plus 27 equals 0. This is a simple quadratic equation which could easily be factorized as 3t minus 1 and t minus 27 equals 0. So therefore 3t is equal to 1 or t is equal to 27. T equals 1/3 or t equals 27. E to the power x is equal to, now we replace this t by e to the power x because t is something we have introduced. We can't leave the answer in terms of t, so we got to come back to x. So t is replaced by ex. E to the power x is equal to 3 to the power minus 1 or e to the power x is equal to 27. Then we can take logarithms here. x is equal to ln 3 to the power minus 1 or x is equal to ln 27. Now we need the final answer in terms of k ln 3. Therefore, I can write this, I can take this minus 1 to the front as x equals minus ln 3 or x equals, I will write this 27 as 3 to the power 3, right? X equals ln 3 to the power 3. Again this power 3 could be taken to the front as x equals 3 ln 3. So the final answers are x equals minus ln 3 or x equals 3 ln 3. Both are in the required format. This is again converting y equals a into b to the power ln x into the linear format. We have to take equation of a straight line by simply manipulating this. So what you can do is to take logarithm on both sides and convert it into a linear format. Once you convert it into linear format, that equation will satisfy these 2 points. So we apply those 2 points in the equation and find values of a and b. Let's see how to do it. What we are given is y equals a into b to the power ln x. So we take logarithm on both sides. Ln y is equal to ln a into b to the power ln x. Now this is a product, so we can write it as a sum. Then ln y is equal to ln a plus ln b to the power ln x. Now this ln x could be taken to the front. This is the power. So ln y is equal to ln a plus ln x into ln b. Now I will write this down in the y equals mx plus c format. Then ln y equals ln b into ln x plus ln a. So this is y, ln y is y, ln x is x. If you want, you can write it as capital Y, ln b, capital X, ln a. Right. Now the 2 points given are 2.2, 4.908, 5.9, 11.008. So we can apply those 2 values in this equation. So 4.908 is equal to ln b, 2.2 ln a. 11.008 is equal to ln b, 5.9 ln a. Now if you subtract these 2, then you will directly get the value of ln b. From that we can find b. We will subtract these 2. 2 minus 1 is 11.008 minus 4.908 is equal to 3.7 ln b. 3.7 comes by reducing these 2, right? Then ln b is equal to 6.1 over 3.7. b is equal to e to the power this b value you can apply in this equation to find ln a. So ln a is equal to 11.008, this should be 008, minus 1.649 e to the power into 5.9. This should be. Now we got to solve this equation. 2 ln 2x minus ln x plus 3 equals 4 ln 2. Again we got to get rid of ln by simplifying it using the log rules. So on the left hand side, this 2 can be taken inside as ln 2x whole thing squared, and this one same, this 4 also could be taken up as to the power 4. That is what we have done this step. Then ln minus means ls division, therefore we can write this as ln 2x squared x plus 3, 2x squared divided by x plus 3, here it is ln 16. In the equation on either side it is ln, therefore we can get rid of ln, using taking antilog, so it will lead us to 4x squared is equal divided by x plus 3 is equal to 16. The 4 is common in both sides, so you can divide both sides by 4x, which will lead us to x squared equals 4x plus 3. X squared minus 4x minus 3 equals 0. So we can write this as x minus 6 x plus 2. We can easily factorize that, right? So x equals 6, so x equals minus 2. We can't take this minus value because when you apply it here it will become a minus inside the logarithm. There cannot be a minus, therefore we will say x equals 6 is the answer. We got to solve this equation using, first of all we use logarithmic rules. ln x to the power 4 minus 4 is equal to 4 ln x minus ln 4. So what we can do is we can take this to inside, ln x to the power 4 minus ln 4. This is log minus, therefore it could be written as a division. So ln x to the power 4 divided by 4. So ln both sides there is ln, therefore we can get rid of ln by taking antilog. So just simply it looks like cut off ln, but it is taking antilog. X to the power 4 minus 4 is equal to x to the power 4 divided by 4. Then we cross multiply by this 4. When you multiply this side by 4, it will be 4x to the power 4 minus 16 equals x to the power 4. Then this x to the power 4 is taken to the left hand side and 16 is taken to the right hand side, which will simplify the equation to 3x to the power 4 equals 16, and then x to the power 4 is equal to 16 over 3. X is equal to plus or minus 16 over 3 to the power 1/4. Again here there is a minus solution. We can't accept this minus solution because ln x can't be negative. So here x can't be negative because of this ln x, therefore we can't accept the negative part of this solution. Therefore our solution is x equals 16 over 3 to the power 1/4. We are given y to the power n equals a x to the power 3, and we are supposed to find equation ln y against ln x. So we will take logarithm on both sides. ln y to the power n is equal to ln a times x to the power 3. So ln y to the power n is equal to, this is a product, so it could be written as a sum using log rules. So ln a plus ln x to the power 3. Now these powers could be taken out as coefficients. Then we can write this as n ln y equals ln a plus 3 ln x. n ln y is equal to 3 ln x plus ln a. I just rearranged it a little in the form y equals mx plus c. So this is ln y against ln x is a linear format. That is what they wanted us to prove. You go to solve another equation. 2 ln 2x minus ln x plus 3 is equal to ln 3x plus 5. First of all, we will take this 2 inside the ln. So ln 2x whole thing squared minus ln x plus 3 equals ln 3x plus 5. This is a minus here, ln 2x squared minus ln x plus 3. So ln minus means the division. So we can write this left hand side as ln 4x squared, this one, divided by x plus 3. This is equal to ln 3x plus 5. Now on either side it is ln, so we can take antilog and get rid of this ln. So which will lead us to 4x squared divided by x plus 3 is equal to 3x plus 5. Now we can cross multiply x plus 3 to the right hand side, which will give us 4x squared is equal to x plus 3 into 3x plus 5. Now if you open this bracket, you will get 4x squared equals 3x squared plus 14x plus 15. Then we will take all these terms to the left hand side to see it as a quadratic equation. Then this will give you x squared minus 14x minus 15 equals 0. So this is a simple quadratic equation which could be factorized very easily. So we get x minus 15 into x plus 5 equals 0, which will lead us to solutions x equals 15 or x equals minus 1. This x equals minus 1, this solution cannot be accepted because it is ln 2x. If you apply it here, ln minus 2, but you can't find logarithm for minus values. Therefore, inside the logarithm should always be positive. Our solution is, only acceptable solution is x equals 15. ln 1 plus 2 to the power x equals 2. So step number 1 is to take antilog and make 1 plus 2x to the power 2, 1 plus 2 to the power x equals e to the power 2. This will give us 2 to the power x is equal to e to the power 2 minus 1. Now we take logarithm on both sides back again. ln 2 to the power x is equal to ln x, e to the power 2 minus 1. X is ln 2, this power is taken to the front back again. X ln 2 equals ln e to the power 2 minus 1. X is equal to ln e to the power 2 minus 1 divided by 2. You can apply this in the calculator and find the answer correct to 3 decimal places. We got to write this equation 5 to the power x equals 3 to the power 4y in the y equals mx form. So what we can do is to use the logarithms. To take logarithm on either side of the equation, so ln 5 to the power x is equal to ln 3 to the power 4y. This x could be taken to the front and 4y as well. So x ln 5 is equal to 4y ln 3. Then we can make y the subject. So y equals ln 5 divided by 4 ln 3 into x. This is actually m. So this is the format they wanted us to show. we got to use techniques of logarithm for this as well. We are given 3 to the power x plus 4 is equal to 5 to the power 2x. Then we take logarithm on both sides. Ln of 3 to the power x plus 4 equals ln of 5 to the power 2x. Now we can take these powers to the front. It's a rule that we've been discussing all this time. X plus 4 ln 3 equals 2x ln 5. Now we can open this bracket here. X ln 3 plus 4 ln 3 is equal to 2x ln 5. Now we take x terms to one side and leave the other terms on the left hand side. 4 ln 3 is equal to 2x ln 5 minus x ln 3. 4 ln 3, now this take this x out, x times 2 ln 5 minus ln 3. So logarithm, you can apply the log rules here back again and write it as x into ln 5 squared over 3. Therefore x is equal to ln 81 divided by ln 25 over 3.